Hello everyone, this is Roy from ZW3D support team. Now, I will give a general introduction about ZW3D CAM. This is the highlight for ZW3D CAM. ZW3D CAM is easy to use and it involves the functionality from 2x turning to 5x milling. And it can provide a faster calculation and accurate toolpath for user. And it also provides a special technology we call Quick Mill for user. With the help of Quick Mill, it can raise the machining efficiency, and the Quick Mill also supports high-speed machining. Besides, it can also work with most important technology like the STL and the point cloud and so on. Now, next, I want to talk the detailed information about the functionalities. The first is the 2x turning. Turning creates a toolpath based on both 2D joints and solid shape, and it supports OD and ID roughing, finishing, groving, threading, and so on. Besides, it also provides the hole drilling and the part-of function for user. Here is the drill and the 2x milling functionalities. For drill, includes the common drill operations like the center, common drill, pack drill, corner bore, and so on. It also provides automatic hole feature recognition function to help user to increase the working efficiency. For 2x milling, it all involves all the common operations like the spiral cut, zigzag cut, profile cut, and so on. Also, it can provide a function that automatically gets the feature recognition. It also can help you to increase the working efficiency. Now here, I want to talk about the 3x milling. This is an important module in ZW3D CAM because among these modules, ZW3D CAM provides a special module for user. We call it a Quick Mill. Quick Mill is a special technology. It can create a flow toolpath and help user to save the reduction in roughing and finishing time. Now here are some highlights of Quick Mill. First, it can create a smooth toolpath. And Quick Mill can improve productivity with efficient roughing and rest roughing, and also it can help user to reduce programming and machine time. With the track function, it also can help user to save the tool cost. It also supports the high-speed machining technology. Besides 2x machining and 3x machining, ZW3D can also provide finish operations for 4 and 5x milling. Now here are two typical 4 and 5x machining parts. In the bottom right, a picture that shows the part cut by ZW3D. Besides the functionalities, ZW3D CAM also has a powerful basic platform. What basic platform can do for user? The first thing is that it provides a simulation. It's a real simulation to simulate the process. And it also can provide an assembly environment to provide visualization environmental machine. The tool library is also very easy to use and also easy to customize the tool according to the real condition. It also provides a built-in post-process for user. It's free. And it also can work for the workshop because it can provide the document report. Okay, that's the general idea about ZW3D CAM. Next, I want to show some example to show how ZW3D CAM works. So let's go to software. Now, I will use this aerospace assembly file to show what's the advantage of CAD/CAM all-in-one software. First, I will change this part with the V function. I change it with the direct editing. You can find that the size of the snout has been changed in this part. Then I will go to CAM level. And to see the tool path. But because of the change, the tool path is not correct now. So how to handle this problem? It is in ZW3D because it is all in one CAD CAM. So just recalculate it. Then we can change the tool path and correct it. Then I will go to the solid verify and verify it to see whether it's okay. So this is what I want to show in this part. In this part, I want to show the new turning module. All of these operations listed here is the operations for this module. First, I want to take a threading operation to show how to operate it. Then we can change some parameters in the parameter form, such as the pitch, thread depth, and the thread position, and the start point, the thread length, and the thread type, and so on. After you finish this job, we can go directly calculate it and get the tool path like this. After that, we can show the existing tool path in the photo. Their facing and the roughing, finish, groving, part off, and threading, and so on. Then we can show all the tool path like this, and then we can go to the output to simulate it. With the simulation, we can view the process clearly and also see the detailed information about this process. From the result, we also can find that it's okay and also it's safe. After it finished the out profile finish, it will cut the inner diameter cutting and the threading and part of and so on. That's what we want to show with this part, turning. In this slide, I want to show not only 3D solid mode can use for ZW3D to create tool path, but also the 2D geometry can be used to create the tool path. Now here we have created all the tool path based on these 2D drawings, and then we can solid verify it to show how it works. Maybe this process can depend on what you need to show it, but here I show all the process. Like this one, I speed up the process to make it more quickly and faster. Okay, we can stop it. And then we can take a feature such as the hole to show how to quickly get the tool path based on the 2D geometry to show it. Now I create all the hole features, use the fit function. Then hide all the tool path we have created. And then use this whole feature to create a drilling option, and then select the whole feature as your machine feature, and then select a suitable tool, drill, center drill also, yes, anyone you want. Then calculate it. Then you can find that the process is very quickly and very easy to do it. It can help you to save the time and increase the efficiency. That's important, I think. Now here, I want to use this flange part to show the whole tactical. First, let's delete all the tool path we have created and then create a new whole tactical. And select the part as the machine feature and set the machine type into 5x. And then directly go to calculate the tool path. And then we can get the tool path like this. It includes the 3x and 5x tool path. Then I will use solid verify to check whether this process is okay or is safety. From this process, we can find that it's safe and quickly. So this is what I want to show with this part, whole tactical.
functionalities. First, I will show the quick mill operations like the roughing, finish, also high-speed machining, and so on. Then I will go to the existing toolpath to show the roughing operation. ZW3D quick mill can speed up the roughing machine process because all the toolpath is smooth flow. And then I will show the rest machining with the function of adaptive feed rate control function. This function can help users to save the tool cost because all the tool paths in the rest machining cut with different feed rate and the speed. Then I will go to semi-finish and directly go to the parameter form with the safety options. And to show how ZW3D check the table, tab clamper, and check collision, and so on. All users like the safety options. Finally, I will show the finish operation with the high speed operation like this. Because this toolpath aided by the high speed machining operation is smooth flow. So it can help users to cut it in high speed. Finally, I will use the solid verify function to simulate this process. So this I want to show in this module, quick mill. Now here I just want to show not only the mechanical part and the coral and cavity can be machined by ZW3D, but also the wood cut product like this also can be cut by ZW3D. Because ZW3D can provide a smooth flow toolpath for such kind of product like this. Now here I just show the toolpath to prove it. And then I will use another artware product, engraving product like this. It is a dragon. I want to use this dragon to show how ZW3D work on engraving industry because ZW3D's smooth flow toolpath can simplify the process of engraving and greatly reducing the program time and effort. That's what I want to show. Now here, I want to use this part to show the multiple frame machining function. First, I will show the interpath with the verify function like this between the two different frames, and then I will go to output. And then output the related NC code to see we can do that for the index machining. So this is what we want to introduce about the index machining. And about the 5x machining, I will use this dolphin model to show the 5x simultaneous finish machining. Then first I will show the toolpath like this, and then use the verify function to show the movement of the tool. Then and also show the data change between the IGK vector. Then, like what you have seen in the screen, then also output the related NC code to prove it. We can get the simultaneous NC code like this. So this is what I want to show in this part, index machine and the 5x machine.